that had it.
Yeah, I'll take it next.
Now, I may, if I can't, if everything gets full, buy two and go download them on two. I've got a hard drive. Yeah, I've got one of those. Yeah. Yeah. The other problem that comes up is production, because I like Photoshop too. So it kind of goes hand in hand. So it's like him waiting to play, or a week, a little over a week's a long time.
Yeah. Long time to wait.
You know, long years ago, I ended up learning from a guy that.
Where's
You guys remember to go through that next thing.
I heard something that seemed like
BHI. Dr. Nutter is a full professor of computer science and electrical engineering.
He's a good guy.
He's a good guy and one of our own. So,
He's one of our own. He is one of our own.
so
If you want to take 2 minutes break, it might be a good idea. I got the projector set up, and you guys in the back.
Crazy. I know. Bob, do you have any change over there? Tens and fives?
I don't think so.
I got a few ones, one is small thing.
This group at least looks okay. I don't think it gets too much smaller.
Can we turn off part of the
He
lights?
wants 10, so he gives you his 20. And there, and there, and
All right, what's this stuff about battery fires?
and it's
Which probably more importantly is what kind of batteries are we using? And I'm sure everybody knows, gee, is that in the way? Oh, that's part of the background. Everybody has some idea of carbon zinc and lead acid and NiCads and nickel metal hydrides and lithium. There's multiple kinds of lithium. Now what I wanted to do was just spend a little bit of time with each one of those so that we could spend a minute. Here's a comparison, and let me kind of stand maybe over here. The carbon zincs, everybody uses carbon zinc or alkaline, and you know that's the old D cells. Here you could pass the D cells around. It says carbon zinc. They're not particularly powerful, but they'll sit on the shelf and last forever. Seems like I could buy them and 10 years later come back and at least half of them are usable. The other half's kind of rotted through. What they've got is an alkaline inside the zinc, and the way it stays charged is it eats the zinc. So when it's done eating through the case of that battery's toast, and so's your flashlight, right? So they're okay, but maybe not for too long. Probably haven't seen lead acid D cells, but they make them. And I did have them, but I don't think I brought them. 25 watt hours per kilogram, just to give you an idea. Think about that as 1 unit, okay? We go to nickel metal hydride, which is what everybody was buying 5 years ago, maybe a little more, and all the radios had nickel metal hydride. And then NiCads go kind of in the middle here. I didn't include them with this. NiCads would fit here. Everybody has NiCads, and I can give you NiCads. Nickel metal hydrides are better by ×4. The problem is 60 to 70, what does that mean? I don't even remember what that meant. Never mind.
Charging cycles?
Whatever that was. Nickel metal hydride's better than lead acid, and probably a little bit safer than just having the acid around. Lithium's where everybody's going though. That's what we want to spend a little bit of time on. Lithium would be, what, 5 times better than just a lead acid battery. Now, let's spend a moment with carbon zinc. Was the first, I shouldn't have done that, was the first dry battery. It was the first single-use primary battery. You use it once, you throw it away. When it's discharged, you don't recharge it. I know you took them and you put them on a charger and you tried to charge them, and it works sort of, but it was a dangerous thing to do, but we all did it. And you never got as much out the second time as you got out the first time. But you could do it. They just weren't very energy dense. Lead acid, probably says that up above the screen, we're used to flooded cell in our car. Lead acid battery in your car is a flooded cell with an acid liquid in the battery itself. You can get those in multiple varieties. One is flooded cell where it's a liquid. The gel cell is kind of the battery that you buy for your boat. They sell 12-volt batteries. They look like car batteries. They're gel cells, and you can put them in your boat, and if it sinks, it doesn't let all the acid out, and you get sued by the EPA. Right? Then we started using gel cells in backups, auxiliary power units, and other devices for your computer. When you bought that, 15 minutes of extra time, and you plugged your computer into it, power goes down, you still got 15 minutes, that was usually a gel cell, and it was lead acid. The next one is absorbed glass mat. Absorbed glass mat are the Optimas of the world. You've seen the red top and the yellow top, and they have a blue top. Those are absorbed glass mat. And what that means is, let's just take a flooded cell battery, there's plates, the plates go down in the liquid, and then the plates have a slightly different chemistry, and you're able to pull the electrons from the liquid, and you can discharge it, you put the electrons back and charge it, and it's in a liquid form. In the gel, it's the same thing, but it's like face cream. They just kind of goo it up, put it in. It works, maybe not quite as well as a flooded cell, but it works. And it can be discharged and recharged, but over time it has the same problem as a flooded cell. Bob, you still running diesel?
Yeah.
Yeah. You still have a diesel?
Oh, yeah, I have two.
How many batteries in it?
Just one.
Just
have
one?
of mine.
I've got two. How long your batteries last?
I don't use them 2 or 3 years.
2 or 3 years.
I mean, I have some.
So we all say my battery's 5 years old and you're working on borrowed time, you might as well replace it. Batteries in my truck are 2005, and they're flooded cell. They're 10 years old. I'm definitely living on borrowed time, but I didn't have a problem when it was cold. So there are some problems. Absorbed glass mat, what they do is, imagine those plates that went down in the liquid and then we gelled the liquid. Now let's put the plates down, but in between them, let's put a fiberglass mat, like a sponge. So put that fiberglass mat in, put the sponge between them. That's an absorbed fiberglass mat AGM battery. That's the red top. Optima and a whole bunch of other people sell those now, but Optima was the first. You buy one, when we first started buying those, they were like 80 bucks. Yeah, now they're like 260. But I'll tell you, I had one with a 1994 battery in my motor home. I sold the motor home a year ago and it was still in it and still running. They'll just sit there and just take a beating. They're a little different, a little higher voltage, slightly different mechanism. They're not 12.76, they're 12.83, a little bit higher. And well, one of the things that happens with those, they'll put them in a car and they're actually undercharging that battery in a normal car. Mercedes put them in for a while and they raised the generator voltage to like 16 volts to take care of charging that absorbed glass mat 12-volt battery, which worked fine except the light bulbs didn't last too long. So they had a problem blowing out all the light bulbs in the car. So lead acid. All right. So I said I was going to do things with your radio. These are lead acid. This is the lead acid battery from Radio Shack out of a camcorder. Can anybody remember camcorders? Anybody remember the cell phone battery? When you had the battery? Those are lead acid. And what you did is you took your cell phone and you plugged it into the battery down in the bag. Those are lead acid. All right, so now we know all about lead acid. All right, so there's another problem with batteries. If you don't charge them, they self-discharge. A flooded cell, I estimate, about 50% a month. You said a flooded cell on the shelf, it's going to lose about 50% of its capacity every month. So the first month, it goes 50%. Second month, it goes 50% of 50 cents. Yeah, it's down 25%. Next month, it's down 12.5%. And if you don't stay on it and charge it over the winter, you know, how many of you park the car over the winter? I bet a lot of us do. And it doesn't move till the next spring. And then when you come out and you crank it, it doesn't do anything, and you measure the voltage, it's 8. Doesn't work. All right, so they'll self-discharge. I could talk a long time about flooded cells. Gel cells a little better. Not real good, but a little bit better in loss per month. But AGMs, oh my gosh, AGMs hardly discharge at all. About 10% a month, I would estimate. I've put them away for the winter, come back in the spring, and it's just like, oh, here I am, I'm 12.8, I'm ready to go. And it starts and runs. So they will sit. I've had AGMs sitting, let's see, on our race car, the last time they were charged was June of 2014. This week we tested it, put them back on the charger. They were like 12.8, we put them away. They were like 12.7 this year. I couldn't believe it. Now, they may not give us any current when we actually load them. That remains to be seen. But they were still holding voltage. So lead acid's not too bad. It's just heavy and not a lot of energy. All right, this does say NiCad. See? NiCad. And NiCad was, I'm going to pass NiCad around. Here's NiCad. Pass that down. I'm going to follow it with some batteries. The old ICOM 2AT battery, NiCad batteries, we had C cells and D cells. Here's a D cell NiCad. You know, that's real interesting because it's nice and light. What's in it is a AA. Get a case that looks like a D cell. Motorola HT used NiCads. This is that old HT200 if you're that old. There you go. My FT whatever it is. Actually, that's got carbon zinc in it because I never leave NiCads in it. I always keep a bag of batteries that I know will work because I guarantee my NiCads are going to be dead. Nickel metal hydrides are going to want charged. And I can go pull those carbon zinc off the shelf and at least it will work. It may not work as long, but it will work. All right, I'll leave that there. Then this one I pulled out of the bag yesterday just for you all. This is, don't tell Parker, but this actually belongs to the University Handbook. There's 2 of these. They're programmable on 440 only. We don't have a repeater anymore. So it's a NiCad battery. It was so dead, I thought, I wonder if this will even charge. And it did. Let's see if it's still holding the charge. And I think it's giving a battery indication. Oh yeah, it says battery bad. All right, I'll pass that. This is the tank-proof radio. You want a tank-proof radio, that's one. And then there was NiCads for your drill. These are 19.2 Sears. This one is extremely bad. It doesn't do anything. Okay. And then they made 9-volt NiCads. Yes, that says NiCads. And then if you got model cars or model planes, here's another one. And this hasn't been charged so long, it's probably no good either. So why do I keep them? Just so I can show them to you, I guess. Problem with NiCads is they self-discharge, so you have to keep them charged. You cannot keep them on the charger because they'll heat up and drive all the liquid out and they're no good anyway. So you've got to put it on the charger, let it go full charge, and then make sure you take it out of the charger. You can't leave it in the charger forever. You can't leave it in the charger day after day after day, or the batteries will be dead anyway. That Ericsson radio is a good example. Okay. Ericsson donated those radios, Parker. Ericsson donated those radios to us, and we used them on the race car for a long, long time. So the batteries are crap, it looks like, so we'll have to do something about that. All right, memory effect. NiCads have a memory effect. And I expect everybody remembers NiCads, because nobody buys NiCads anymore. What would happen is, if you had a good NiCad that would give you, well, let's say full power out on transmit, and let's say maybe a couple amps at whatever voltage it's running, 9. And then you let it set with it on receive for a week or two, and then you tried to transmit, it would act like it's a bad radio. Because this memory effect, where it was drawing 15 milliamps for 2 weeks, it would decide it's a 15 milliamp battery and never give you that 2 amps again. You could charge it, discharge it, charge it, discharge it at 2 amps, and it would get rid of the memory effect and you'd have a 2 amp battery back. But most of the time people don't do that. They'll put it on receive and let it receive forever, and then it remembers it's a 10 milliamp battery and it thinks it's a 10 milliamp battery, and that's pretty much the end of that. All right, let's see, what is this about? Nickel metal hydride. 20% per month, nickel metal hydride. I got a bunch of them over here. Here's nickel metal hydrides. Again, off my really good Icon 2AT. That is nickel metal hydride out of a Ford electric truck. That's, I think, nickel metal hydride. It says on it, and I don't have my glasses on, out of a Black & Decker screwdriver. All right, so get that going. They come in AA's, in AAA's, and now instead of going to a carbon zinc in the HT, this is out of my HT or one of them, all right, you can use a nickel metal hydride, and it will not self-discharge quite as fast as a NiCad. So you can charge it up, and it'll be good for a month or so, and then you need to charge it again. So, let's see, I'll send that around that way. Now, this guy is nickel metal hydride, and this is really what nickel metal hydride looks like. It's flooded cell, whereas those have got an absorption in them like a foam, right? Inside of this, and let's think lead acid battery has acid inside, and I could say, this is a lead acid cell, and you'd all believe me. But this is a nickel metal hydride cell, and in it is potassium hydroxide. So you got just the opposite problem. You have acid all over your garage floor, now you have lye all over your garage floor. Instead of acid eating a hole in the concrete, you got lye eating a hole in the concrete. And I can prove that it does. I have a place up in the engineering building that I try not to show people. I don't know, it was on charge, and like an idiot, I put water in it before I charged it. Bad idea, because it expands. When it charged and expanded and went out the overflow and dripped on the floor, it's like kind of a funnel place right in the floor where it ain't not a good idea. All right, let's look at lithium batteries, and there's primarily 3 kinds. Okay, lithium ion, which is a lithium cobalt, sometimes called LiCO. It's 3.7 volts per cell. Why is this important? Every one of you's got one on your belt or in your pocket, somewhere on you right now, and you don't even have your radio. These are all lithium ion. Okay? I don't think any of them yet are using lithium iron phosphate for these applications. I think it's coming. I just think the industry hasn't caught up with it yet. But the way to tell, if they don't tell you, is how many cells are there. And you can tell that this one's a little bit lower voltage cell. Now, I started seeing these again with the electric vehicle business, but these are in your cell phone. These are probably in your new radio. If you bought a handheld in the last, that out of your cell phone?
That's not a cell phone.
Okay. Hang on to that thought. I would not pass it around. The reason I won't pass it around, I got a bunch of them over here.
Oh, okay.
Thank you for reminding me. As long as I don't short them and start a fire.
Yeah.
All right, these are lithium ion batteries. Move that guy. This is somewhat, the packaging is a little bit different than Randy's. This is out of an older cell phone. But that's a lithium ion. I'm going to pass that around. You can take a look. You've probably seen them before. If you've got the $49 Chinese radio, it is lithium ion as well. That's lithium ion. If you haven't taken your own apart and looked at it, you might want to do that sometime. There's a problem with those. This one is out of a laptop. That one is pretty okay. This one used to be this size. Okay. This one was a fire waiting to happen that didn't quite catch on fire. All right.
Are these the ones they don't want to put in the airplane holes?
Yeah, I'm going to show you some video in a minute of the airplane stuff. Lithium ion, and you can see where it's kind of bubbled out. It was really nice, two nice cells, nice and flat. And what they did is they overcharged it.
Wow.
This is out of one of our robot projects.
So you can overcharge a lithium ion battery?
You can overcharge them and they will do that, and you can undercharge them and they will do that. Well,
Kind of cranky.
It does say this.
here is another example out of a laptop.
It's the first thing it says.
This is not exactly what you want to see happen.
Nice.
This is what it should look like, and this is what it looked like before it caught on fire. Now this one gassed. Thank goodness it didn't catch on fire, but I've seen them do it. I was working in a business out south of town. We had a laptop, and he was doing some testing on some equipment, and the technician came running in out of the lab, and he says, "Laptop just caught on fire." And I thought, yeah, well, you were testing 110 volts. That's what he was doing. It was going back to the laptop. You got the ground in the wrong place, or it's wired wrong. Big deal. We'll fix it. And we got to looking, and he hadn't done anything wrong at all. It had just self-combusted. The only way to say it. It had burned a hole right up through the keyboard. And what it was plugged in and on charge. Now the charge mechanism probably didn't work. Remember I said you could overcharge them? Bad news. You can undercharge it. It's bad news. Toyota Prius. Have you seen any fires? Heard of any fires? No. I only heard of one out of the probably well over a couple 100,000 of those vehicles at this point. But what they do is they never discharge below 50%, and they never charge over 80%. They keep that narrow band on the Prius. It works. On your radio or your cell phone, Those controls are all built into the charge mechanism, which is generally in the battery. Generally in the battery itself. So there's a computer in the battery that watches temperature and it watches voltage. If it goes over voltage, it shuts down. If it discharges too far, it shuts down. If you don't have that control and you keep discharging, it'll catch on fire. If you don't have that control and you try and charge it on a power supply without any controls, that's what it's going to look like. They are going to do that first, and what happens is this chemistry. This is a lithium cobalt, actually 02 or 04, 02 I think. Anyway, what happens is it starts to generate oxygen and blows up. I mean, it just gets bigger. The gases in it expand it. And then it starts to get hot. And then once it gets hot, it's exothermic. It lights itself off. And what it will do is it'll just self-combust, is what it amounts to. And the real thing is heat. As it starts to get hot, it's a feedback loop that just makes it hotter and hotter and hotter, and then it catches on fire, and then that heats the cell beside of it, and it catches on fire, and that catches the plastic on fire, and it catches your laptop on fire, and that catches your carpet on fire, and then your couch, and then your house, and then you're very unhappy. How many times have you heard that happen? Not many, except for the airplanes. We used to see it on airplanes, but I don't think you've seen any of those recently at all. And why not?
We have rules against
They are doing the electronics right on charge discharge. Usually when they catch on fire, they're on charge. They've got them plugged into the charger. The charge mechanism that is supposed to control that is not working. So I've got a video I'll show you in a minute from the FAA on how you put that fire out. How many of you know what lithium is? Lithium is one of those metals that you get air on it and it burns by itself. They're lithium batteries, but the lithium inside these batteries is not free lithium. So I'm not aware of any batteries at this point that have free lithium that would self-combust like that. What happens is this chemistry. Let's go on here and I'll go back up. LiPo is lithium polymer. Remember, this lithium ion is that bag I'm passing in. Okay? LiPo also looks like a bag, but what they do is they put a polymer in between the plates. Okay, so it's got like a plastic in there. It's a little better, but it still can self-combust. The lithium iron phosphate batteries are what's being used in the Tesla and in the new electric and hybrid cars that are coming out. When they say they have lithium batteries, it's usually this technology now. Okay? Actually, I think your Toyota Prius has lithium metal hydrides, now that I think about it. Does it?
lithium metal. I don't know. I mean,
I think it's
they
lithium
don't-
metal.
They really don't tell you anything about
Does it?
it, except
Depends on how new it is, but the older ones, now that I've thought about it, do have metal
I know
hydrides.
that the one morning I heard, not from Prius, but on a discussion group that I then stopped listening to, was that you don't ever want to, if you run out of gas, you don't want to push battery only very far, because
That's
you
right.
can completely discharge the battery, and that can then cause the car to
The
burst.
problem is the same. If you overheat them, which you would do if you were over discharging, then that starts a fire. The internal air inside of most of these cars is blown through the battery container and out. So when you have the air conditioner on, you're actually cooling the batteries as well. When you have the heat on in the wintertime, you're actually heating the batteries as well. So it's like all the rest of our electronics. It likes to be in the same temperatures and humidity that we do. All right, so let's hit this rather. Lithium polymer, you can sit on the shelf, it's pretty good. Lithium ion though, and lithium polymer is one of those, the day it comes out of the manufacturer, starts to deteriorate whether you use it or not. You cannot put them on the shelf and save them for 5 years and expect them to be any good. They will start to deteriorate the minute they're made. So I guess what that means for our cell phones and handhelds is that we're just going to have to plan to buy batteries as this world goes on. Unless you buy his add-on and put carbon zinc in, or alkaline, or AA nickel metal hydrides. Are we seeing AA lithiums? Yes, you are. I like that better, but depends on what the technology is as to whether how much I like it. You know, I worry every time I charge my laptop because I know it's a lithium battery, and I sit in the family room leaning against the couch on the floor and I go to bed. I've got so that makes me nervous. Didn't used to make me nervous. Makes me nervous now. I know too darn much.
Now I'm nervous.
Now you're nervous. Well, the question is, what do you do? Put it in the garage on a concrete floor? Put it in the basement? Yeah, but I'm not going to put it out there at 0 because lithium won't charge when it's 0. It likes to be warm. So that doesn't work either. Starts to degrade at the factory. They're telling us 2 to 3 year lifetime. I don't believe that. My laptop's 5 years old and I can't tell any difference at all in the battery. I still get 4 hours. So I don't super discharge it though, and I depend on the charger to work, or else I probably wouldn't be able to sleep at night. Okay? Heat's the killer. If it heats up, it degrades them, so you want to keep them cool. If you completely discharge a lithium ion battery, it's toast. It's done. You will not recharge it. The little bag, there was a double bag that came around laying over here now. We built a little microcomputer that was actually smaller than the battery, and we had little modules, and I left one hooked up too long and went, what happened? I forgot to charge it, whine, and the battery was dead. And I thought, big deal. Put it on charger. Yeah, there was no recovery. Once they get down to toast form, they're toast. Might as well buy another one. So complete discharge is not a good idea. It didn't catch on fire. It just was no good. Must have onboard complete computer management, and that's why your cell phone works. It's why that battery works. Why you can charge it and trust it. It's why my laptop seems to be trustable. iPads, yeah, I guess so. I haven't heard of any problems with them. I'm going to show you a movie in a minute. Make you nervous, but if you treat them badly, they don't like it. But if you treat them well, they're pretty good. Undercharge or overcharge, I said that before, is going to result in a fire. Okay. I have to look, see what I said. Batteries produced, oh, all right. These are still lithium ions. While providing high capacity, they're more reactive and have poor thermal stability. Remember, you got to keep them cool. Susceptible to thermal runaway. If you start to heat that battery, or it starts to get hot, leave it in your car in the summertime, probably not the best idea. All right? Leaving your cell phone in the car while you go do something and the inside of the car gets 140 degrees. It's not over excessive, but that's pretty hot. They're talking 130 somewhere. High temperatures greater than 130 degrees C. 140 Fahrenheit's not even close to that, so it's not really that hot. Perceptible thermal runaway if you short circuit it, or you drive a screwdriver through it, or you hit it with a hammer, impact, or you sit it on a hot plate, or you put it in the oven. I actually heard of somebody who tried to kill their wife by putting a lithium battery in the oven, and when she preheated it, it blew up. Not cool. or if over discharge or overcharge. High temperatures are bad. High temperatures generate oxygen. The oxygen reacts with the organic electrolyte, the liquid that's in there, and then it becomes exothermic, which, boom, you got a fire. All right. Here's a picture of a laptop. This one didn't quite go over, but you can sort of see one of the cells here. This one got shut down before it got completely obeyed. All right, guidelines for lithium ion. Lithium ion batteries contain little lithium. Remember, lithium in the free air burns by itself, so there's not much in there. So how would you put out a fire on one of these? Just like you put out any other fire. It's an electrical fire. Don't put water on it. No, put water on it. Because what it does is it cools it. And the kicker here is exothermic, so you got to get it cold. Cool it down, flood it with water, flood it with water, flood it with water. If it short circuits, big deal. Flood it with more water. And once it gets below that self-igniting temperature, you're probably good. I've got another video that will run if you want to stay and watch it. The FAA it's a training video for the FAA about laptops on airplanes. One catches on fire, what are they supposed to do? And they hit one with a water fire extinguisher, perfect. They hit it with the chemical dry, it works, but the problem is it doesn't cool it. It puts the fire out, but if you walk away in 2 or 3 minutes, another cell is going to pop off and it's going to be on fire because it's still hot. The other thing they did is they covered a laptop with ice. Took a bucket of ice and it was bounded up over it. And it caught on fire. There was fire floating out of the ice. Because ice is an insulator. I wouldn't have thought that. But yeah, the cool was not getting inside to where the batteries were, whereas the liquid you can pour around it and it'll kind of go. But the ice was insulating it, and what was happening is in a few minutes it was lighting off the cells and blowing fire out between the chunks of ice. Not what you would expect. So water is the way to get rid of it. If you have one that's on fire, bottle of water, Coke, don't pour whiskey on it. Alcohol probably is going to make a bigger fire.
You're wasting good whiskey.
At least you wouldn't care.
The other thing that they recommend is don't pick it up. Because about the time you pick it up, it'll blow up. So depends on where you are, what you're doing. If you can throw it outside, I'd throw it outside, but the best thing is cool it. Be aware of cell propagation. If one cell goes off, the rest of them are going to go right with it if you can't cool it off. Goal with water is drop the temperature. Okay. If you have a dry chemical extinguisher for electrical fires, you can use it. It's supposed to be at class D on lithium metal or potassium, but there's not enough free lithium in these batteries to create that kind of fire. There are batteries who use free potassium, there are batteries who use free lithium. You probably will never see it. We had a sodium, can't remember what the other chemical was, a sodium battery in town once. It was in a vehicle. And they had to keep the battery container at like 600 degrees. Because if it ever cooled off, the container would crack and the sodium would catch on fire. So it used the battery as a heater to heat the battery. And you had to charge it every 24 hours or else go buy another car. For best results, dousing a lithium ion fire, use a foam extinguisher, CO2, dry chemical. What's the problem with dry chemical? You get chemicals everywhere and it doesn't cool it. It'll put the fire out, put the flame out, and it's good with electric, but there's not that much electric going on here. Okay? Copper powder, you throw soda on it, like you would a grease fire, that'll work. Doesn't cool it, it'll put the fire out. The worst thing is, once it's doing that nonsense, the problem is you've got it catching everything around it on fire. It's not just the computer itself. Okay, let's look at lithium iron phosphate. Lithium iron phosphate is safer than lithium ion. What has iron phosphate? Like I said, Tesla, A123 batteries, if anybody remembers those, they were a big business that took $500 million to revolve the money and then declared bankruptcy. And then Tesla bought them, what happened to them? Chinese bought them, Chinese back in business selling them as A123 batteries. They have a long cycle life. A lead acid battery cycle life's about 300 to 500 cycles, charge, discharge. Think about that in your car. 1 year, every day, 365 times, but you're not completely discharging it. So that's why you're only getting a couple, 3 years out of them. These batteries are 2,000 to 7,000 cycles. So if you have this in an application like, I always think of the electric cars again, but if you had one in an application for your HT, this battery probably going to last forever. You'll probably keep the battery and trash the radio. Yeah. They can be quick charge. You could charge one of these in about 30 seconds, doing a dump charge. And as long as it doesn't overheat, remember you still got the heat problem. As long as it doesn't overheat, you can do that. The Nissan Leaf electric car, and now who else? BMW and I think the new Bolt that GM's coming out with have a quick charge connector on them as well as the normal charge. And the quick charge is a big connector with DC, and you put like 400 volts DC at 200 amps into this thing, and you stand back, watch Fort Martin lights go out, and then you unplug it, and you're up to 80% charge.
Wow.
Yeah,
Put up your water machine.
it's just a fuel. It's like refueling your car.
Yeah.
But think where all that came from. You know, Fort Martin lights went out. And they spend the rest of the day charging the battery they don't charge from to get it back up so the next guy can use it. But they are doing that. They do exist.
The little Mitsubishi electric car also has 2 charging ports. If you get one, I had
That's
one
right.
on a borrow, and you get the low charge, you plug it in at night, and you get up the next morning, it's mostly charged. But there's another port that they don't give you the charger for, and I gather it's because you need.
That's the quick charge.
Yeah.
They got type 1 and type 2, which take the standard thingy.
Yeah.
And then the quick charge looks more like a airplane charge connector, if you're familiar with that term. Plus and minus.
They all look
A
somewhat.
little bit
like-
bigger than the
They
airplane.
all look somewhat like a gas tank.
Yeah.
I think that was done psychologically.
Well, I think that was probably the idea.
Yeah.
All right, here's a Tesla fire. Tesla S. This is the Tesla. As far as I know, there have only been 2 of those fires with Teslas. This one, it turned out the guy ran over a trailer hitch. It was laying in the road. And it rolled up underneath and punched a hole in the battery. So Tesla fixed it by adding a skid plate. They brought the ball back and they put a skid plate under the battery pack. And I don't think they've had any of those fires since then. That's been a couple of years. There was another one caught on fire in Mexico, and the guy was drunk and he ran into the fire hydrant, ran up on the fire hydrant, and put a hole in the battery. So, on both of those.
If you have a fire in an electric car, and I'm thinking again, because I got one, what would a well-trained fire department do? They would bring water?
Back away.
What they
There's a lot of
should
electricity
do,
there. I
what
mean,
they should do
There's a lot
is
of.
there's an app for their phone, which they should have, that goes to here in Morgantown to the National Alternative Fuels Training Center. They have an app that they can look up that type of car. It will show them where to cut the car, where the high voltage is. And the idea is disconnect that battery if you've had an accident. If you can get the switch, usually there's a disconnect somewhere. But there must be on that app 200 different vehicles that have hybrid or electric, and they show where they use the jaws of life and cut them and where not to. Yeah. So that's what they should do. What they will do, I'm sure, is another question. All right, I want to show you a couple of them. This one takes about 10 minutes. Let's skip that one. He said, well, I know it was within 6 feet of where the battery was charging for his electric grill. So
Pretty good indicator.
they're guessing that that's what started it. I said, where was it? Sitting on the concrete in the garage. I find that hard to believe. So,
That would be a safe place.
well, you would think, but apparently it wasn't for him.
Yeah.
Well, the thing is, with a fling like that, I mean,
It's
you can,
low.
yeah, you got, it
Yeah.
could be several feet away and catch something on fire.
So-
It's in the garage on the floor, but it's next to the lawnmower gas can.
I've got to trust Apple. And having had it as long as I have, I do. I have a, if you Google Apple fires, I don't think you're gonna find any. If you Google Dell fires, I don't think you're gonna find any recent ones.
I have a
But if you have
battery
a
that would make a
Chinese
difference.
knockoff, you might want to be a little more nervous. Or a Chinese knockoff.
So what seems to be the design flaw in the hoverboards? Is it,
Charge control.
okay,
They're overheating them by over discharging. The one I saw a picture of on the news is just running till it's, they're just running and running and running. That's letting them do it. It shouldn't let it do it. It should shut down.
I think it goes back to what you were saying about the cheap Chinese knockoff. It tends to be the cheap Chinese knockoff hoverboards. that-
You know, what they're saying is when the lawsuits come, all they will find is an empty garage where there won't be anybody there. Probably right. Any questions? Other questions?
I have a couple of lead acid batteries, and I'm not sure if they're truly the glass pack batteries. They were advertised as that when I bought them. They've been sitting charged, well, they were charged a long time ago, probably about 3 years. Will that have an impact on the overall lifetime of the battery?
Yeah, because what'll happen is the plates will change and calcify, and you won't be able to get the same capacity you got out of them when they were better, new.
Okay.
Measure the terminal voltage, and the way I do it, if it's over 12 volts or actually over 10.8, it probably recharge. If it's below that, it's probably got a cell that's bad, and it's not gonna work. You can charge all you want. It'll go and look charged, and then you take it off and wait 20 minutes, and it'll be back to 11. That's a throwaway.
Okay. Yeah, I bought them a long
But
time
if
ago.
it charges up, it's like our absorbed glass mat batteries in the race car. If it charges up, I'm impressed, but we haven't really run them under load. They'll probably run, but not well.
I think they've only been through like